Normally it's okay. Like
Yeah,
you
sorry
read
for this session. By the way, I shared the reading material to Google Classroom, but I don't know if everyone see it or not.
let me check. Mm, 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 mm,
Yeah,
mm.
welcome. Hello.
Right.
Um, oh, let's just wait for, a few minutes. I think people are coming. Yeah, yeah.
Yes.
Uh, how are you, Harsh? Harsh, right? Uh,
Yeah. I'm
uh,
Harsh.
I thought that it's kind of nickname, but I believe it's your name directly, Harsh.
Yeah, so like in my language, it doesn't mean like what it usually mean in every other
Oh, okay,
language.
I see.
So my parents never thought that I would interact with anyone outside of India, so they named me Harsh.
Okay, I see now. What what does it mean in your language?
I
The
couldn't get you,
meaning.
sorry.
Oh, sorry. What is the meaning in your language?
Harsh means excitement, like I'm very
Oh,
Excitement.
happy,
thank you.
something of
Exci
that sort.
Oh yeah,
Oh,
yeah. It means someone who's
I see.
happy and complete opposite of whatever it means, like in
Okay,
any question.
I see.
Arshia is actually happy-go-lucky.
What?
My nickname, surname in India, like no, in like normal one is like so, but in India is means something else.
Oh, really? I don't know. I think it's a bad
Is
meaning or something like that.
I
Yeah,
see.
yeah.
it's mean pea.
Oh, really?
So yeah, my nickname is a bad name, is a bad word in India, you know.
From now on, I will use Susu for you.
No chance.
It's better. It suits you.
So let me just put a message on the chat. That not good. Mm, 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 mm. All right. Oh,
Let's just wait for 2 minutes, and after we can start.
sure. Um, alors, week, c'est le quatrième,
Yeah, okay.
quatrième semaine? Wow. Okay. Okay. Right, let me just put I'm
I think
present.
in the invitation it says session 6, but it's session 7, right?
Yeah,
Yeah,
session 7.
yeah.
Week 4, session 7. Week 5, 4,
Week
5,
4.
4,
4. Yeah,
session
4,
7.
not 5.
Check inbox.
By the
Where do you
way,
live,
I would like
Harsh?
to wish.
Oh, someone was talking. I'm
Sorry, I
sorry.
couldn't. Yeah.
Where do you live? Or are you
I've
digital
been,
nomad like Holland?
yeah, kind of digital nomad for quite some time, but
Ah,
right now in Dubai,
okay.
but
Okay, I
hopping around
see.
most.
Okay, like Holland. Someone was talking. I'm sorry I interrupted, I believe.
Yeah, so I was like, Happy Diwali to all my Indian folks here. It's Diwali and I'm celebrating it with you guys. So,
Yeah, it's a big Hindu
Oh, is it
festival.
Diwali? Oh, really?
yeah, it's
Yeah.
a festival of lights and yeah, happiness.
Should we say congratulations or I don't know what to say? How to,
You can just say happy
Happy
Diwali.
Diwali? Happy
Yeah,
Yeah,
just
Diwali.
wish happy Diwali.
I see. Okay, I
that
see.
should be good enough.
Okay, I think we can start. People attend later, a few minutes. We shouldn't wait more, I think. Let's just start if you're ready, Harsh.
Just a
Definitely.
second. Let me just do some. I'm just making sure that, I am switching off all sorts of notifications so that I
Okay.
don't get disturbed because I have this thing where like if I see a notification, like my mind just goes like this. I guess I have some sort
Okay.
of PK probably.
And
Uh,
also, we don't read
okay.
your private message. So it
No,
would be
not
better.
more like it's just like even could be, yeah, that's definitely true as well. Like I work in privacy. I don't want people to be, yeah. Cool. Is my screen visible? Uh,
Yes.
cool. Yep. Uh, oh, why is it at slide number something something? So what is this going to be about? So I thought about it, that like what's the best way to probably present this, right? Like introduce the concept of Aztec to you all. And I thought that rather than, like me talking about every concept about Aztec, me talking about everything that exists there, I will just try to nerd snipe you all. So basically, I will give you a general gist of things. I will try to give you, like what's the problem that we're trying to solve? What cool stuff can you do with it? Some small concepts, like I won't go like into too much depth of the architecture because I don't want you all to get bored. Like I want you to organically go through our docs and like slowly like absorb more and more. But right now this workshop is gonna be like what's Aztec, why we are building it, what's something cool that you can do, some basic architecture around it, reading some basic noir code, and we're gonna do like a real demo of a real privacy app that we have been building inside Aztec. And then we can see how things goes. Like I'm more than happy to answer any questions around anything. I'm not the best slide maker, so you would have to deal with very, like childish looking hand drawn slides. But yeah, let's get started. So my name is Sarsh. I work at Aztec. I do a lot of experimental projects inside Aztec. I would say my job right now is like one of the most interesting one to a lot of people, which is like to nerd snipe people into Aztec. So I just build cool shit, which is a really privileged thing to do. So yeah, let's get started about it. Oh, I already introduced myself before the slide. It's fine. So what's the problem statement that Aztec is trying to solve, right? And so if you look at blockchains today, everyone can see everything on blockchains, right? So Satoshi Nakamoto came up with this paper, and everyone was like, oh, this is a new way of doing finance. And there were some people who were able to see it back then. It actually took me a lot of time to be in blockchains and actually see through that, oh, that's a real problem that everyone can see whatever is happening between these addresses. Because somewhere we all have this assumption that if I am 0x something, some sort of an address on a blockchain, I am private. But that's not true because there's something called chain analysis. People can basically go through a block explorer, they can run various algorithm. AI is getting really good at it, and they can start linking you, right? And it becomes worse than cash, right? Because it slowly becomes more and more and more, like not so private. And that's the thing, like that's what cryptos was set out to solve. It was like set out to solve, to give human humans freedom of using their money how they want, as they want, right? And we can debate the philosophy around it. I'm more than happy to answer it later on. But right now, that's the problem, that blockchains are public. Every trade that you make, every amount that you send, anyone can see it. People can do chain analysis, people can do various techniques. uh, and that's not great. Like you don't want people to be seeing that you are buying a taco, you're buying, like a $10 subway, you are watching the specific movie in a theater. You just don't want everyone in the world to be able to, like mine on top of this data. So what's the solution, right? And the solution is to build a private world computer. And what do I mean by that is that if you look at how crypto started, it started at Bitcoin, where you had this publicly traceable but self-sovereign money. So what you mean by that is that there's this digital store of value. Back then, it used to be the goal was to make a digital peer-to-peer scalable cash, but I guess we somewhat stopped at just making it a store of value. And it's traceable. Basically, yeah, anyone can know which address is sending what, but this self sovereignty, right? So there is digital money and it's public. But then, basically, post Bitcoin, everyone started making their own proof of work blockchains to solve a specific use case. So someone was building a proof of work blockchain just for creating a naming system. Someone's like doing some sort of a game on top of it. And that there came the problem that, like, oh, Bitcoin is not programmable. So you cannot build on top of its security. So much energy is being spent on Bitcoin, but you can't do much with it beyond just basic transfers. And that's where you could say Ethereum came up with this vision of becoming the world computer, where you have this digital asset ETH, and you can also program it. You can build an exchange, you can build lending markets, you can build NFTs, and all of this stuff you can build on top of Ethereum, right? And we saw the whole DeFi summer. Similarly, but Ethereum is also public. Everything that you do on ETH is visible. Like every trade that you make, every NFT that you own. That's my one of, like, for example, if you go to hushbashpay.eth, you can see, like every NFT that I own and stuff like that. That's why I actually don't use hushbashpay.eth. I just use it for my ENS, but I would never use it for anything serious, because anyone can go to hushbashpay.eth and find out, like, uh, my on-chain transaction patterns, which I don't want you all to know. Cool. So similarly, like Zcash came up, where their goal was, back in, like, I guess Zcash started with the zero cash paper back in 2015, 2016. I don't know, like, but like sometime like there, where they identified this problem with Bitcoin, and they said, we need a private store of value, right? So basically, they made Zcash. Zcash is just like Bitcoin. It has a 21 million supply, but it's completely private, and you can basically spend it without anyone knowing what you're doing on Zcash. So it's completely private digital money. But again, it's not programmable. So it has some like Bitcoin like constraints. And that's where we come to Aztec, where it's like the private world computer, where not only you can privately transfer money, you can program it, you can build like a DeFi app with it, you can build private NFTs with it, and you can interact with all of these applications while being completely private and being protected by, like ZK snarks. So what is a layer two? Because Aztec is a layer two system on top of Ethereum. So unlike everyone else, we are not trying to build a L1, like a layer one or a chain of its own. We're trying to tap into the security of Ethereum, so that from day zero of Aztec's launch, because we're going to do stage two launch, Aztec is as secure as Ethereum. It has the same economic security. And now I've used this word layer two, so now to explain what it is super quickly. L2s basically allows you to delegate execution of chain. So what do I mean by that? Is that right now, when I say basically swap X for Y on Ethereum, the computation of swapping X to Y from Ethereum is also happening on Ethereum, but you can basically delegate it. So you can just post the transaction data on Ethereum, and then some other entity like a rollup will basically do the compute and will just send the result, right? So that's what a rollup is. A rollup is an off-chain system where transaction execution is happening. All the data is available on the layer one, but all the compute gets delegated to layer two. And it offers two, like one of its main benefit is scaling, where you can get compute for like way cheaper than how you would get it on Ethereum. And the second is basically you can construct systems which can inherit Ethereum's security. So we can now build Aztec. And since Aztec settles on Ethereum, it is as secure as Ethereum. So the only way to compromise Aztec is now to compromise Ethereum, like to revert a block or do something illegal uh, on Aztec, which is, and by illegal, I mean like outside of the protocol, and Aztec is like by basically being able to control Ethereum. So yeah, we get Ethereum grade security from day zero at Aztec. And we provide a complete privacy stack. And what do I mean by that? Is that we have smart contracts. So unlike Zcash, it's not only transfer of money, you can program money, you can give it some rails, you can like build all sorts of applications with it. You can have both private and public state. So what do I mean by that? I will get to it pretty soon. We provide client-side proving software. We provide you Noir, which is a really nice language to write smart contracts and ZK programs in. And we allow you to compose various private smart contracts. Now, I've said a lot of stuff like what does that mean? Let's just try to, like quickly see through it. So client side proving and private state. Basically, when you're on other blockchains right now, you send a transaction to basically update some public transparent state. So for example, if there's a counter on a blockchain like EVM, then you send a transaction to this EVM chain and you say, hey, increase my value by one. The counter's value zero is basically visible to everyone else in the world. And the new value of the counter one is again visible to everyone on the world. On the other hand, on Aztec, you can choose if you want this value to be private or public. If you choose it to be like public, it will just work like this. But if you choose it to be private, then comes the real magic, where basically you will client side prove that. So, like the value is completely private. So, if someone would look at Aztec, they can't figure out, like what the value of this counter is. So, it's not visible publicly. But then you can basically add to this private value by doing a client-side proof. So you can read this value, decrypt it because you have the keys associated with it, and then you can generate a client-side proof saying that whatever private value I'm going to give you should be the new value here. And this gives you mathematical guarantee that whatever operation I did on top of this value is indeed correct. So you could basically have private counters, right? Like a lot of other private stuff. But the basic idea is that on Aztec, you can have private state and you can operate on private state by client side, executing them and proving them, and then just verifying the proof on Aztec, which leaks nothing about this value, right? So that's basically about like what's pretty unique about client-side probing and private state. So on Aztec, you get to choose what state you want to be public and what state you want to be private. So for example, you can decide to make a mobile payment app where all the volume that the mobile payment app is doing is public. So this way, anyone can trace that, like, oh, this is whatever is happening through this app. Like it's auditable. People know that whatever money has got into the system is consistent with whatever money has got out of the system. Uh, and at the same time, you could decide to keep the transactions private of who's transferring what, right? And I'm going to show such a system in practice pretty soon. Uh, so yeah, so basically, and I said another part which is like it's composable. So what do I mean by that is that you could have multiple private smart contracts and they can call each other, and that's pretty nerd snipey. Basically, because it means that someone can have a DEX and someone can have a money market where you could basically privately swap first on the money market, on the DEX, and then lend that money on a money market. And you can chain these two transactions together such that either one, either all of it happened or none of it happens. So you can basically do Ethereum style composability where smart contracts can call smart contracts. A private function of a smart contract can call a private function of a smart contract. So you could have, let's say, smart contract A, private smart contract B, private smart contract C. They could compose with each other, and whatever private state was updated will remain private to you, and whatever public state was updated will now become public to everyone. So it also means that you can have a transaction which firstly does some private stuff and then at the end updates some public state. So you can do all these sorts of really cool patterns on Aztec. So damn, this shit is cool, right? Basically, when I saw it for the first time, it took me a lot of time to get it, and it's fine if it's like a little bit confusing, and you're like, "How's that possible? This is possible." Like, it was completely the same for me. It took me some time to read through the docs, to build some stuff, to basically get the general idea of it. But once you start getting it, you're like, "Damn, this shit is so cool. We can do just so much on it." Like it's an open canvas for new ideas, and that's why I really like it uh, because there has been this focus on scaling blockchains, and I personally handled a lot of research around scaling blockchains. But I've seen that not a lot of new use cases have came out of scaling blockchains. Like so, just giving 100,000 TPS hasn't given us a lot of new use cases. Uh, but on the other side, I believe having the ability to build completely private apps does gives you a lot of cool stuff to do, right? So what can you do? You can build a private neobank. So right now you cannot build a bank on Ethereum because who wants everyone to see what their balance is, right? But on Aztec, you can basically have like a complete banking system where you are giving yields to the user. So basically it's tapping into some ETH staking yields, you're privately earning interest on top of it, and you can spend through it, you can attach a card to it, and you can completely bank yourself on Ethereum via Aztec while being completely private. You can build a private DEX where your trades are hidden. So where like who is making the trades are hidden, and you can even keep the trades hidden if you want. Like you could use certain techniques to do that. But yeah, so you can build like a private Uniswap, you can build a private Aave, you can build a compliant private DeFi system where basically you could say only someone who's you could basically prove that okay, if you want to use my private DApp, you can only use it if you have never interacted with a blacklisted address, right? So you can do like all these sort of things. You can build a governance platform which is completely private, where all on-chain voting happens on Aztec, and it's completely private, right? So okay, but like I've said a lot of stuff, but can we see any of it in action? Because I can open, I can create 15 slides of how we're gonna get to Mars, but if I don't have a rocket, then we're not gonna get to the Mars, right? So let's just do a quick demo, and the demo will be of a private OTC market, uh, and I will also show you some Noir code of like how the stuff works, and probably I will not bore you all in the process of it. Oh, I came to the thank you slide very earlier. But I will very fastly go to, I will firstly go through, like through the article that I wrote so that we can understand the problem statement. The problem statement is that right now, if there's an over the counter trading happening, if a seller is interested in selling Bitcoin for, let's say something like USDC on base, then if they give someone some money on Bitcoin and if they give someone some money on base, someone can easily link it. They can say, hey, like this was a trade between these two people. So all the OTC right now is visible on public transaction graph. And you might say, no one cares. But there are times when someone does care, which was, let's say, if you look back when what happened with the Curve founder in 2023 is that he was trying to basically, I guess, sell some stuff OTC to save his liquidation positions, and it was visible on the blockchain graph, so everyone could see that the founder of Curve himself is dumping the token, and the token had big effects. Like it had a lot of really big issues because of that. Like there was a lot of drama that was created. Now, one can debate that, oh, it was actually good. He was dumping tokens. People should get to know. But that's not the thing. The thing is that this can happen in any different scenario as well. Whatever you're doing, whatever you're selling through OTC markets is actually visible on public blockchains and their transaction graphs. And I think we can solve this. So we at Aztec thought about, like how could you solve this problem? And we were like, okay, what if we could build a non-custodial private OTC market where the volumes that this market is doing is public, but who is selling to whom and what is being sold is completely private, right? And the way this works is basically, so yeah, the problem statement is that the seller should be able to sell one ETH for 5,000 USDC because I want ETH to go to 5,000 USDC, and then be able to buy someone be to able to buy like 5,000 USDC for one ETH. And yeah, so they like few simple processes that happen here. So there will be a seller, and a seller will deploy a private escrow contract on Aztec, right? So the project is open source here on Aztec Pioneers, Aztec OTC Desk. And basically, what this escrow contract on Aztec is supposed to do is basically allow the ability to deposit privately, which means that, first of all, no one should be able to know that you are trying to sell something. Whatever you're depositing into this contract, where let's say I want to sell one ETH, so I'm going to privately deposit one ETH into it so that no one out there can know that I have deposited one ETH into this escrow contract. And then I'm going to create something called as a partial note. And what's a partial note? I will just try to keep it very simple here because it would take us on a tangent. but more than happy to answer this question later on if someone really wants to dive deep into it. Basically, a partial note allows Alice to be able to get some money from Bob without Bob knowing who Alice is on Aztec, and vice versa. Like you can try to enforce vice versa as well if you want. So basically, let's say if Alice is a bakery owner and Bob has just bought like a piece of bread, then if Bob pays her directly on the blockchain, then Bob knows the whole volume that Alice does on her shop. But with the Aztec, you can basically use something called as a partial note, which is the piece of data that Alice can give to Bob. And when Bob fills the amount that he wants to pay, the only thing that Bob knows is that Bob paid someone some USDC, like this amount of USDC, but Bob doesn't know to whom they paid. So they don't know who Alice is on Aztec. They just know that they paid some address, this amount, some amount of USDC, and that's it. They don't know who Alice is, and that allows Alice to completely privately take payments on Aztec. So we're going to use this construct here, where basically what the seller does is that once it deposits the token into the escrow, let's say 1 ETH here, it's going to say, hey, here's my partial note, and basically anytime someone pays 5,000 USDC to this partial note, give them the ETH that I've locked here. So this allows the seller to receive payment privately for their order without the buyer knowing, because they're just paying to a partial note as we described here. Cool. And then there's this service called the order flow service. I'm going to quickly go through it, but it basically helps people discover orders. So let's say if there's someone who's ready to buy these orders, they need to know that there are these orders that exist out there. So a seller can optionally record this into an order flow service unless they just know whom they're going to sell to, and they are directly going to give them the address of the order details. They can expose it to an order flow service, and the order flow service doesn't know who the seller is. They just know that someone is ready to like sell this much amount of some asset, but they don't know who, right? So that's not even known to the order flow service. And then comes the buyer side of it. The buyers are looking at, oh, someone is willing to sell 1 ETH for 5,000 USDC, and if a buyer is interested in it, then they will basically privately call this smart contract. They will transfer their 5,000 USDC to the partial note, which will basically cover the payment for the seller. And then the smart contract will privately give them their basically ETH, 1 ETH for it. And in this scenario, the buyer doesn't get to know who the seller is, and the seller doesn't get to know who the buyer is, right? So that's kind of how the system works. So I'm gonna now quickly go through the code and then a demo. So if you look here, if you go like you can later on go to the repository, you have this main.noir file, .nar file in contracts. And this is what Noir looks like. So it's a very Rust-like language, I would say, which you can use to write private smart contracts. So every smart contract basically is written inside with this specific syntax, which is, let's say, pub contract and then your contract name. And then you have basically this specific macro that's required to, like decorate a contract, and then you're importing like stuff. So basically, uh, yeah, these are like basic imports. So if you have like used any programming language, like if you use TypeScript, think of them as import statements. I think like Python also have like import statements. So yeah, like just think of them being able to import library code. And here is the stuff here. Let's say we define our storage and we say we have a private immutable value. And what we mean by that is that this value will only be recorded once and no one can change it, and it will be private. And what does this value look like? This is the content of the value. So the value basically records who is the owner of this escrow, who does, like what's the partial note, what token is being sold, what token is being like how much is being sold, what token is being bought, and how much is being bought, and some randomness here, which I will skip for now, but you can think that it's for security purposes that we add some stuff here. So yeah, so basically you store in the storage of the smart contract all of these details related to the order, and no one else in the world can see these details. It's only visible to the seller and the buyer. It's completely private. Like you cannot go to a blockchain explorer and like find all of this data out. And then just like how we have constructor in normal programming languages. We have initializers here, which is basically initializing the storage values. So here basically the seller, when you create the contract, you provide the address of the token you want to sell, how much you want to sell, how much you want to buy, and what is the address of the token that you want to buy. And then you create a partial note to which the payment has to be made so that you can privately get your other asset in. And then you basically uh, initialize your storage with this data, right? And the act of initializing the storage will make sure that this value here is filled. Like all of these values are now filled, and now they cannot be changed, and they will remain private and only known to the person who created it and has the keys for this contract. So once the escrow has been created, then you go ahead and deposit your token. So you will basically deposit, let's say if I want to sell one ETH, I will, and if you look at here, like we have defined hashtag private. So what hashtag private means is that this function runs client side on the user's device, and a proof of it will be generated, but it won't be executed on Aztec. It will be ran completely client side, right? So that's what the hashtag private stuff means. So now we are gonna allow. So anywhere you see private, you now know that it's like running on your own device and it's completely private. So yeah, the act of depositing is basically you depositing whatever token you want to the contract. So the contract will now hold it. So for example, if you want to deposit one ETH, then you will privately transfer one ETH to this contract, and now this contract holds the one ETH, and it will only release it when someone will pay you 5,000 USDC or whatever amount you have set in exchange for it. Right. So that happens. And then there's this very simple function, which is again completely private, which is fill order. Where if a buyer is interested in buying this order, they will come here and they will basically pay the smart contract the required amount of tokens. So let's say if they want to sell 5,000 USDC, they're going to sell 5,000 USDC. And yeah, then basically the contract will give this 5,000, will pay this 5,000 USDC to the partial note. So, and then basically it's gonna give the ETH back to whoever is like willing to buy it. I'm sorry if it sounds a little bit confusing, but I tried my best. But yeah, like it's basically this, like there are these three functions. Constructor initializes the value. You have the act of depositing, and you have the act of being able to fill orders. All of it is completely private. You can go back and check out the code. I won't like read the code line by line, but I hope this gives you some context, like of how a contract is written on Aztec. Like this is the language is Noir. We have documentation around it. And yeah, it has like very Rust-like, a lot of Rust-like constructs. Okay, cool demo time. I've bored you all enough. Uh,
So sorry,
bye.
we
Oh,
have a question on the
oh,
chat.
oh.
Maybe we can check it.
Yeah, sure. T- t- t-
Can you
what
see,
does
or
it
I can read it?
mean?
Huh.
I can see it. So, what does it mean? That one, right? Like, what does it mean that the attributes are totally private? If someone is sniffing the activity on Aztec node, they can access this data or not. No. So let's say if what I mean by, and let me also read the line right in the ENV where the smart contract is executing. Yeah. So good question. That's a really good question. So the thing is that anytime something is private, it's not actually executed on the node, it's executed on the user's device. So anytime you see any function which has this private attribute to it, it's being executed on the user's device, and only the proof of it will be verified on the Aztec node. So all the private compute that happened there is, yeah, completely private. But if it was a public function, then it would be executed on the Aztec sequencer and the node, and it would be visible. Yeah. Um, cool. So I think let's go through a quick demo of this thing in action. Uh, yeah. So we're gonna do there's this thing. Is there a new question? Okay, cool. Thank you. So yeah, so we're gonna like, so if you go to the repo, like I will like tell you what you can do so that if you want to run this locally, you can as well. If you go to the ATC Aztec OTC disk repo, you can check out this branch, but we're gonna merge this on main. So main should also work for you once we merge it. You can go to, and you would have to do like a bun install, which will build the whole system for you. I'm not going to do it right now. And then you have to go to packages, and then you have to go to contracts. And now you see this Docker file. So we're going to start something called as an Aztec sandbox. So basically Aztec ships with this thing called as a sandbox, which is basically a local devnet, you could say that, which has an Aztec node. It runs Anvil, and you basically have like a complete Aztec instance on your system running, and you can like develop stuff on it, right? So we're gonna like start a Docker file that does a bunch of stuff here for that. So yep, I'm gonna quit it here. Um, it's the command call. Okay, cool. So I'm gonna do run sandbox, and it's gonna run sandbox. It's gonna run something called PXCs, but I'm not gonna get much into a PXC right now. I think it could be a lot for someone to grasp in a single go, but more than happy to help answer any questions around it. So yeah, I've started like a local instance of Aztec now on my system. It's settling to an Anvil based Ethereum chain. And now we can come to the CLI here and we can show some cool demos. So the first step is to deploy some assets to Aztec. And if I'm gonna say setup deploy, it's gonna deploy USDC and ETH to Aztec. You can later on check the scripts. But yeah, it's going to deploy two tokens because if you're gonna do OTC, we firstly need some tokens on Aztec. So we are like just deploying two dummy tokens to Aztec, and now I'm very soon gonna be a millionaire on testnet. So just watch that out. Uh, cool. Yep. So basically, we were able to deploy uh, this stuff on Aztec. We were able to deploy USDC contract and a ETH contract on Aztec. You can see some logs here as well. Probably okay. It's Docker, so probably a lot of logs are being mixed. Cool. Then the next step is to basically, so if we come and look at the balances right now, if we print the balances, bundling balances, we're gonna see that the ETH balance for like the ETH and the USDC balance for the seller and the buyer both is zero. So how are they gonna exchange something if they don't have any assets? So we're gonna run this script called run setup mint, and this is gonna mint some assets for them. Yes. So basically, 10 ETH was minted to the seller and 50,000 USDC was minted to a buyer. What's that? It's not worth a million. We should change the scripts to at least make people millionaires here. But yeah, so yeah, if we now run the balances, we can see that, let's just see. Yeah, we can see that the ETH balance is like a big value, but because that is expanded. So like we are using the way system here, where I think one ETH is like 10 raised to the power 18 way. So that's why it means 10 million, like 10 ETH, sorry, right? And then same for the USDC. So we have like 50 USDC, but 50,000 USDC. But again, it's expressed in the system where the smallest, where let's say one USDC is 10 raised to the power 9 or something like that, or 10 raised to the power 6. I don't know. Like I'm confused about how many powers there are, but yeah. Cool. But the thing is that now we need the ability to be able to transfer one ETH from the seller and be able to get 50,000 USDC from the buyer. So if you look at like a successful OTC order should allow the ETH balance of the buyer to be basically one, and the USDC balance of the seller to be 50,000. And of course, both of these values need to be changed accordingly as well. So we're gonna create an order first, and we need to now run this order flow service. Okay, run. Yeah, yeah. So now this order flow service is what helps the buyers here to be able to discover orders. So if we look here, if I do bun run order create. Now it's going to create an order, which means that it's going to deploy an escrow contract to Aztec saying, I am giving you one ETH and you only give this one ETH to someone if someone gives 5,000 USDC to my partial node. So we're going to say bun run create order, and now like an escrow is being deployed to Aztec and all of these parameters are being set. So you can look here, like the contract is getting published and then it's going to get deployed. Cool. Yep. So it got deployed. OTC order was created, and you can see that the order was also discovered by the order flow service. So now anyone who's a buyer can basically query the API here and see that there's an order for something, but they won't know who is trying to sell it. And if we now run the balances stuff, we see that the ETH balance for the buyer is 0, but you can see the ETH balance for the seller changed. They dropped 1 ETH, and that 1 ETH is now deposited to the contract. So now when we would fill the order, is where, let's say, the buyer of this OTC will discover this order through this order flow service and will give 5,000 USDC here and will get 1 ETH back. And all of that will happen completely privately. So it says found a matching order to fill, attempting to fill order. I hope it passes its attempt to fill the order. And yes, finally. So yeah, like a transaction happened. And now if we were going to go and look at the balances, we can see that we can see that the ETH balance is 9. It got 50,000 USDC, 5,000 USDC here, and the ETH balance of the buyer increased by 1. So we can see that they were able to privately exchange these assets without knowing each other, which is really cool. It's basically like, if you look at it, it's actually like a completely private order book, the way it works. So the code for it is available on GitHub on Aztec Pioneers, and you can go and spin all of this on your own. And I guess I pulled off the impossible of getting a live demo actually working without any error. So yes, that's a very weird thing. Usually doesn't happen. Something always breaks. But yeah, cool. Yeah, so that's about like some live demo of an application on Aztec. And thank you. I don't wanna keep expanding on it. Yep.
Can we send the GitHub link to the Telegram group? I think it
Yes.
might help. Or it chat also works, I
Yeah,
think.
I'm gonna send it to the chat. So this is the GitHub
Okay.
link, and this is the link
Thank you very
of
much.
the article. Yeah.
Let me send this to Telegram group. And if we have any questions, you can ask for Harsh.
Yeah. Yeah. Augusto, if I'm pronouncing your name correctly. Yeah.
Okay, thank you. My question is, why use Noir instead of Rust or other programming language? I didn't understand that.
Yeah, that's a great question. Basically, Noir already looks a lot like Rust. But the thing is that making the whole Rust language work for like being provable client side would be very expensive. So basically, when you are doing zero knowledge proofs, you want something that's very efficient. So Noir is designed from first principles about how do we create a language that can be proven really fast on client side devices. And Rust as a language with all of its feature was never designed for that. Like it was never designed to be proven. It was just designed to be executed. So that's why we have Noir, which basically allows you to write like super efficient client side software, which is client side provable. Like, does that help? Like, oh yeah, Carolina, like, am I pronouncing it correctly? Like,
Yes, thank you. Yeah, thanks for the talk. Maybe you know this project that I'm sharing in the chat, Kohaku. I just wondered what's your opinion on it and how Aztec is positioned regarding what they are doing.
yeah, I haven't like so I've heard about Kohaku, but I haven't like really got into it. But from my understanding, this is just my understanding or whatever I've seen till this far about Kohaku is that they're basically like trying to use like privacy pools for Mavens and stuff like that. And Yeah, you could technically integrate Kohaku with Aztec. But I think like they aren't trying to do what we are trying to do. They're trying to just use other protocols like Aztec, which is, let's say, like a protocol on Ethereum, uh, let's say something like 0xBOR, and route transactions through it. And Kohaku could technically route transactions through Aztec as well. But what do I think about only doing privacy directly on Ethereum? I think it's very hard to get a big anonymity set, and you again run back into the same problem that you cannot program stuff. So let's say if Kohaku integrates with, let's say, private transfers and sends through something like 0xBOR, which is a privacy pool. Now, you still can't do private swaps. You still can't do private lending, right? So if Kohaku integrates with something like Aztec, it can do private swaps, private lending, private OTC, and all of that stuff. So I think like uh, Kohaku as a wallet is basically something that can be expanded to Aztec. And I think the kind of protocols that's going to integrate with right now, yeah, like might not be that interesting, but yeah, it does look like that they're interested in integrating with layer 2. So yeah, like I think it's gonna be pretty complementary. So like they're gonna just like we can just integrate it with Aztec. Yeah. And the good thing is that Aztec has native account abstraction, which means that your Ethereum keys can directly work on Aztec. So your MetaMask can technically work on Aztec.
Cool. Very interesting. Thanks for sharing.
What practical considerations should one keep in mind when deploying and executing applications on Aztec, particularly regarding the interaction between public and private state and on-chain verification? I would say like the practical consideration while writing uh, client side like noir programs is that the more optimized the better. So like firstly I'm just going to talk performance, which is basically making sure that your contracts are as less by like consume as less bytecode as possible, because the bigger your circuit is, the more your user is going to spend time generating a zk proof. So you should basically try to write like reason through a lot of like about your code. So I would say that's one thing that you definitely need to think, that I've written this program, but can I make it go faster? Because it going faster means the user being able to prove it faster. uh, on the security side of it is where, like, if your public function in Aztec is basically responding to any call on a private function. So let's say if a private function calls your public function, then you need to make sure that whatever happened in the private function is something that you are satisfied with. So let's say a private counter. So yeah, so let's say a counter where the value is public, but you can add any value to it in private, right? So now what's going to happen is that rather than someone adding the value in public, they're going to add it in private and just give you the result, right? And oh yeah, like, and there could be an even simpler example, which could be in base and an exponent. Yeah, so let's say base and an exponent problem. So let's say you have a value of 16 and you basically have a public value of 16 on Aztec, and you are saying if someone can find the factors of this, let's say like if someone can find a base and an exponent, like something we've raised these many times to the same value would give 16, I'm going to reward them some USDC for doing this computation, although this computation is pretty simple. So now the private function of the user is going to look like, I know a base and exponents, which could be 2 raised to the power 4 or 4 raised to the power 2. Like the public function doesn't know which out of it is, which will result into 16. So your public function just needs to make sure that whatever private function the user called is something that actually verifies the logic that they're interested in, which is, let's say, base into exponent is equal to 16. So I think that's the thing. Like every time you are doing any public action based upon something that was run private and client side, you need to make sure that whatever happened on client side stuff is what you're fine with. So if that makes sense.
I have a question.
Yeah.
Yeah. So, what do you think about privacy in blockchain gaming or in gaming in general? Where I'm coming from is I and my team are working on a poker game, and we have recently completed building a Uno game on chain. So, what's your opinion? Because I had also attended Aztec's community call where uh, Joseph Andrews had openly mentioned that uh, blockchain gaming is a good use case, especially poker. So he couldn't highlight more, but I would like to have your outlook on that because we are building that and we are actively building that for Aztec as well. When we have spoken to Josh, so if you could just highlight
Yeah,
on
so I
this
think
subject.
like I like it. I actually yesterday tweeted about it that if someone is building this, more than happy to help architecturally. I think it's like Aztec would be really cool to build games where the strategy cannot be revealed on chain. So, for example, poker, like you cannot build poker on Ethereum because like no one can actually know like who has what cards, right? So, if the cards are visible on Ethereum, then there's nothing left to speculate. So you could basically have a private shuffling of cards on Aztec, and I think you can bring a real poker game to blockchain, and that's really epic because I don't think most people have like I haven't seen someone actually be able to do it. Like I've seen papers, but I've not seen someone actually get like a real system in production without any trust assumption, like stuff like that. So yeah, I'm pretty bullish. I think you can build like a lot of strategy game on chain with it, where me not being able to know your strategy is very crucial.
So, thanks. Good to know that you're bullish on it. And I would like to connect with you if for a meeting with my team, that would be good because we are actually hitting few roadblocks because we have been exploring building on Aztec. Josh has been helpful, but yeah, if you can guide us, that would be great.
Sure then. Yeah. Like I'm on Telegram, so yeah.
Do we have any other questions? I believe not. Thank you for this session, Harsh. It was amazing. And if you have
Yeah.
any other questions about Aztec, Harsh is on our Telegram group so that you can, text him. And yeah, thank you very much.
Thank you. Yeah, I hope it was helpful in some capacity. Yeah.
It was really good. And you're right.
Yeah.
Always, while trying to do a live demo, something happened, but this time it was amazing, like very fluent.
Oh, yeah, yeah,
Congratulations.
yeah. Thank you. Yeah. See you all. Happy Diwali too.
Yes.
We're
Thank
celebrating it.
you.
Yeah.
Yep, yep.
Yeah, thank you. Bye bye. Take care.